Hello, my dear students. So today we'll take on movement area method, one problem. So first we'll take a problem here. Determine the slope at support. Determine slope at supports and deflection at the point where load is acting. Load is acting by movement area method. By movement area method. So the problem is like this. A simply supported beam AB of span L is acted upon by a point load W at a distance A from support A and B from support B. So for this we have to find out slope at supports, that is theta A, theta B, and then deflection at the point where load is acting. Let us take the point as C. So first we have to find out the reaction. Let us take sigma MB is equal to 0. So RA into L is equal to W into B. Therefore RA is equal to WB by L. We know this, right? So once we determine RA, we have to find out RB. Let us take this as sigma Fy is equal to 0. So RA plus RB is equal to W. RB is equal to W minus WB by L. After taking LCM, it is WL minus WB. So take common W, L minus B by L. So in figure you can see L minus B is nothing but A. Therefore this I can write as WA by L. This is nothing but RB. So let us take MC, find out moment at C. So either take left or right portion. So MC means what happens? RA into A or RB into B. So RA into A. We have calculated RA. RA is nothing but WB by L. So WB by L into L, which is WAB by L. This is moment at C. So the bending moment diagram will be like this for this type of loading. So this is WAB by L EI, M by EI diagram. So now what we have to do? We have to find out slope. So to find out the slope A, we have to consider AC portion. If I need to find out the slope B, then I have to consider BC portion. Right? You get same. So now theta A is equal to area of M by EI diagram between A and C. Right? Area of M by EI diagram between A and C. So theta A is equal to, this is triangle, half into base is A, height is WAB by L, EI, half into A into WAB by L, EI, which is equal to WA square B divided by 2EIL. If I take theta B, then half into base into height. Which is equal to WAB square divided by 2EIL. So this is how you have to find out the slope at support. Now we have to find out delta C, that is deflection at the point where the load is acting. So delta C is nothing but moment of M by EI diagram between A and C. So one thing what we have to remember is, when we are drawing a triangle which is not a right angle triangle like this, then what we have to do, the distance of that one, if I take the distance from here, this distance will be L plus A by 3, and if you take distance from this point, then this centroid distance will be L plus B by 3. This we have to remember. It's not like 2/3 of base. In this type of a problem, it is L plus A by 3, or from here it is L plus B by 3. When you are finding delta C, then it is moment of M by EI diagram between A and C, about A and C about A, that is from A. Moment of M by EI diagram between A and C about A. So moment means area into perpendicular distance. So area is half into base into height into the perpendicular distance is L plus A by 3. So when you simplify, you get delta C is equal to W A square B divided by 6 EIL into L plus A. Okay. So this is how you have to calculate the deflection and slope for a given simply supported beam when this load is not acting at the center. So now let us take one small problem of same kind. Determine the slopes at support. Determine the slopes at support determine the slope at support and deflection at C for the simply supported beam shown in figure by moment area method. By moment area method. So you have a problem here. 300 kilonewton A and B. This is 3 meter with EI and 6 meter with 2 EI. So you have to calculate theta A, theta B and delta C. So first what we have to do is we have to draw the bending moment diagram. So to draw the bending moment diagram, first we have to find out the WAB by L. So WAB by L is equal to 300 into 3 into 6 by 9. So you get 600. So you have 600 by EI. When this 600 is divided by 2 EI, it will be 300. So it is like this. 300 by 2 EI. So this is how you get a bending moment diagram. You get 600. Here EI is 1 EI. So 600 by 1 EI. Here it is 2 EI. So 600 by 2 EI will be equal to 300 by L. So once you consider this, now what you have to do is you have to find out the theta A and theta B. When moment of inertia in a simply supported beam varies like this, we have to remember first we have to find out the deflection and then we have to find out the slope. That is, we know that here I can write this like this: tan theta A is equal to delta AB by L. So this concept we will be using. So delta AB, now we have to calculate. Delta AB is nothing but area of, sorry, not area, moment of M by EI diagram, moment of M by EI diagram between A and B about A. So moment of M by EI diagram between A and B about A, that is from A, that is delta AB. So we have to find out that delta AB. So delta AB is equal to, area is half into base is 3 into 600 by EI into centroid of that is 2/3 of 3 plus half into base is 6, height is 300 by EI into 3 plus 1/3 of 6. Alright. So now simplify this, you get delta AB is equal to 6300 by EI. Okay. So now if I write delta BA, delta, first we will find out theta A. Theta A is equal to delta AB by L, that is 6300 by 3 EI. Therefore theta A is equal to 6300 by 3 is 2100 divided by EI. So this is how you get theta A. And if I take delta BA, that is moment of M by EI diagram between A and B about B. So this we will be considering from B. So that is equal to half into base into height into 6 plus 1/3 of 3 plus half into base into height into 2/3 of 6. So simplify this, you get 9900 by EI, which is delta BA. So we can write theta B is equal to 9900 by 6 EI. L is 6. So L is 9 actually, right? Here it is not 3. L is 9. It's 9. So 9. It means that 6300 divided by 9. That is 700. 700 overall span. So here also it is 9, which is 1100 by EI. When you consider theta A and theta B, here you have 700, here we have 1100. So what we do, since tan theta is small compared to B, we consider theta A is equal to theta B is equal to 1100 divided by EA. So this is how we will be calculating. and always we calculate in a reverse way. So smaller one will be theta b, therefore we take theta b is equal to 700 by. So we have calculated theta a and we have calculated theta b, right? So this is how we have to calculate. Now to calculate delta c. Delta c is nothing but moment of m by ei diagram, moment of m by ei diagram between b and c above b. So that is half into base into height into 1/3 of 6, which is equal to 1800 by ei, that is delta c. So what we have to do is we have to substitute this in an equation, because we know that we have one formula here. We know theta b is equal to delta c plus delta cb divided by LCB, or we can equate this to this one. Theta b is 700, so 700 by ei delta c plus whatever we have got is delta cb, so 1800 divided by LCB is 6. So what we have to do is, this is ei and this is 6, this is delta cb, right? So now calculate for delta c. So when you simplify this, 700 into 6 divided by ei is equal to delta c plus 1800 by ei. Therefore delta c is equal to 2400 by ei. So here few things varies because of this 2a. If it is just simply AB, then it will be simple. Here we have considered 2a also. So first slightly I will explain this one. I will recall this one. So first moment is WAB by L, 30 into 3 into 6 by L, you get 600. So here it is EI, therefore 600 by EI. Here it is 600 by 2A, so it is 300 by EI. So what we have to remember is tan theta is delta AB by L. So delta AB by L means we will be considering moment of M by A diagram between A and B from A. First we have to calculate that. Later we have to calculate moment of M by A diagram between A and B about B. That is we have to consider from B. Once we calculate both, the bigger one we will be considering that as theta A, and the smaller one will be considering it as theta b. Once we calculate this, we have to calculate delta cb. Delta cb is nothing but moment of M by ei diagram between b and c about b, or you can write delta ca, then it will be moment of M by ei diagram between c and a about a. So here it is delta cb, therefore moment of M by ei diagram between b and c about b. So once you calculate that, we have a formula which we have to remember, that theta b is equal to delta c plus delta cb by LCB. So we need to calculate delta c. So to calculate that delta c, what we have to do is substitute for theta b. Theta b is 700 by A, which is equal to delta c plus delta cb we have calculated just now, 1800 by A and LCB. So take this on this side, you get 700 into 6 by A, and take this on the left side, so you get this, and finally delta c is 2400 by E. So this we have to remember. Thank you.